Dear friends, derivative of a function using first principle. What is this first principle? We have discussed earlier. Again I write it. F dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. This is the definition of derivative or the first principle of differentiation. Using this, we shall evaluate two derivatives respectively of x to the power n and e to the power x. First of all, the x to the power n. Friends, we take fx is equal to x to the power n. Therefore, f of x plus h is equal to x plus h whole power n. So, f dash x, that is ddx of fx, and fx is equal to x to the power n. So we can write ddx of x to the power n is equal to limit h tends to 0 f of x plus h minus fx upon h. That is, we substitute limit h tends to 0 f of x plus h means x plus h whole power n minus fx, that means x to the power n upon h. Limit h tends to 0, we write again the numerator as usual, x plus h whole power n minus x to the power n divided by h. We can write this h as in this way also, x plus h minus x. Okay, so friends, if we substitute x plus h as z, then keep a look at here. When h tends to 0, then obviously z is tending to x. So we can write limit z tends to x plus h, that is z power n minus x power n whole divided by x plus h is equal to z minus x. So friend, limit z tends to x of z to the power n minus x to the power n upon z minus x. What is the formula we can use here? We know that limit x tends to a of x to the power n minus a to the power n upon x minus a is equal to na to the power n minus 1. So we can use this formula. So it will be n x to the power n minus 1. So from where we have actually started, we started from this part, ddx of x to the power n. Now finally we got nx to the power n minus 1. So friends, what is ddx of x to the power n? Derivative of x to the power n with respect to x is equal to nx to the power n minus 1. This is a formula of differential calculus, and using this formula we can solve many more examples. Derivative of a function using definition, and the definition is f dash x is equal to limit h tends to 0 f of x plus h minus f of x upon h. This is also known as the first principle of differentiation. We shall find the derivative of e to the power x. Friends, first of all, we take this function fx is equal to e to the power x. So f of x plus h is equal to e power x plus h. Therefore, f dash x, that is equal to ddx of fx means e to the power x is equal to limit h tends to 0 f of x plus h minus fx upon h, that is equal to limit h tends to 0 f of x plus h, that is e power x plus h minus f of x, this is e to the power x upon h. Friends, if you are new here, please subscribe the channel and see the complete video. Now friends, limit h tends to 0, we can take e to the power x common. So we take it here, e to the power x, and in bracket e to the power h minus 1 whole divided by h. Now we can write this as limit h tends to 0, e to the power x is outside of this limit, e to the power h minus 1 upon h. Since h is actually tending to 0 and h varies, so e to the power x is free from limiting condition. So this is equal to e to the power x into 1. We know this formula, limit h tends to 0 of e to the power h minus 1 whole upon h is equal to 1. So the result is e to the power x. Friends, ddx of e to the power x is equal to e to the power x. We write it again, ddx means derivative of e to the power x with respect to x is equal to e to the power x. This is also a formula. Thank you. Have a nice day.